Hello everybody, welcome back to Absolute Value. Today we're going to do one more IB practice, and we're going to do a problem from section E. This problem is worth 16 whole points, and so I'm going to show you how to get the maximum amount of points on this question on your IB test tomorrow. So to start, they give us f of x equals ln of 5x over kx. And we want to show that f prime is this. So basically we are just going to take the derivative. So the derivative of f of x is a quotient rule. It's the bottom times the derivative of the top, which is 1 over 5x, times the inner part, which is derivative of 5x, which is 5, minus the top times the derivative of the bottom. So the derivative of the bottom is k times the top, which is ln 5x, all over the bottom squared. We can simplify this a little bit. We have an x here and an x here. Those can cancel each other out. We have a 5 and a 5, those as well. And we have a k in each term. So take a k, take a k, take a k. So then we would just be left with 1 minus ln of 5x all over kx squared. And then there we go. That's what we just proved. Part B says the graph has exactly one maximum point, P, and find the x-coordinate of P. So in order to find that, we need to set our derivative we just found here equal to 0. So in order for this to equal 0, we know that the top would have to equal 0. 1 minus ln of 5x would equal 0. Add ln of 5x to both sides. And to cancel out the ln, we need to exponentiate both sides. That cancels that out. And then we're left with e equals 5x, so that x is e over 5. So now part C tells us the second derivative of f is given by this, and the graph has exactly one point of inflection q. Show that the x-coordinate of q is 1 over 5 times e to the 3 over 2. So basically all we do for this one is we find when the second derivative is equal to 0. So let's take the second derivative that they give us, set it equal to 0. Do ln of 5x minus 3. Then top equal 0. Add 3. Divide by 2. So we have found that the x-coordinate is in fact at 1/5 times e to the 3 over 2. Part D says, given the area of R is 3, find the value of k. Well, the way we find that area R is we know this curve is f. It's bounded by p and q. So we just use p and q, the x values of p and q, as our bounds for the integral. So for D, we need to do the antiderivative of the original f function, which was ln of 5x over kx, from the bounds that we just found for p and q. So p was, and we know it equals 3. So let's just take the antiderivative of this guy, and then we can use that in the end to find out what k is when the answer is going to be 3. So here we have a bit of u-substitution, and I'm going to set my u to be the top there, the ln of 5x. Means du is 1 over 5x times 5 dx, or just 1 over x dx. So that means whenever we plug in for dx, is going to be x times du. So now let's plug everything in terms of u. Then we will get, I'm going to just take the 1 over k and put it on the outside of the constant multiple. Then we'll get the antiderivative of u over x times x du, because we just substituted in for dx, this guy. And notice these x's cancel each other out, so we're just left with the integral of u du times 1 over k. This is a very easy integral to solve. It's just a power rule. So now it's u squared over 2 over k times u squared over 2. And then let's plug our u back in. 1 over k times ln of 5x over 2. Oh, this is squared. And from our bounds of e over 5 to 1/5 e to the 3/2. Now if we just plug in those numbers, we'll get So we'll get a final answer here of 5 over 8k. And since we know that that's equal to 3, we can solve for k. And there's your final answer. So this problem looks like it's going to be a monster because it has so many parts to it. It has graphs and taking derivatives and integrals, but really it's just a matter of a u-substitution turned it into a power rule. So this is a good example of what you will see on your section B of your IB math exam tomorrow. So hopefully that helped, and feel free to leave comments if you have questions. Also subscribe to see more videos of review and math concepts and other things like that. And check out this other video that I have here that is for some section A problems on the IB math exam. Thanks for watching and happy studying!